Now we will go to a different chapter here called Differential Equations. Now first of all, what is meant by differential equation we will see. It is an equation containing derivative of unknown functions. Differentials can be present in place of derivatives. See, suppose for example, consider this equation. X into dy by dx plus y is equal to 0. See, this involves both variables, that is, and a derivative. Dy by dx is a derivative. See, this derivative involves both variables x and y, as well as derivative of dy by dx, derivative of dependent variable with respect to independent variable. So y is the dependent variable and x is the independent variable. As x you give values, y will change. So that is why it is called as independent variable is x, dependent variable is y. So with respect to independent variable, such an equation is called differential equation. Such an equation with an example we have explained here. That's all. Next. Now here next topic is order of a differential equation. Next topic is the degree of differential equation. We shall see first order of differential equation. What is order of? Now let us consider different differential equations here. See, it involves both variables, derivative. dy by dx is equal to e to the power of x. This is one differential equation. Second differential equation, d square y by dx square plus y is equal to 0. This is the second differential equation. Now third differential equation, d cube y by dx cube plus x square into d square y by dx square is equal to 0. Now you can see the highest derivative is the order of the equation. In the first case, the highest derivative is 1. You can see here. Don't confuse with the serial number 1. That is dy by dx is 1 order. Next, d square y by dx square, you can see the derivative is 2 here. That is why order is 2. Similarly, in the third equation, you can see the derivative is 3. Therefore, the order is 3. So, therefore, the differential equation from the above tabular column, the highest derivative of differential equation is the order of the differential equation. Highest derivative here it is 1, here it is 2, here it is 3. Therefore, the orders are 1, 2 and 3. Now, we shall see the next topic of degree of differential equation. Degree of differential equation. Here we have written one equation here, differential equation. You can see here d cube y by dx cube plus 2 into d square y by dx square whole square plus y is equal to 0. Now here you can see the order of the differential equation. Order of the differential equation is 3, highest derivative. Highest derivative of this equation is 3. Therefore order is 3. But the degree is different. So the degree is the power raised to the highest derivative of any differential equation is called degree of differential equation. The highest power raised to the highest derivative. The highest power raised to the highest derivative of any differential equation is called degree of differential equation. As such, can you say what is the highest order of highest derivative is this? You can see here, highest derivative is this. The power to which it is raised is 1. Therefore, the degree of the differential equation is what? It is equal to 1. That is how this degree of differential equation is defined. Now we will see now here, I will write the degree of any differential equation is the highest the highest derivative. Raise it to the highest derivative of any differential equation. Have you seen here? Therefore, as such, the degree of this equation is equal to 1 because it is the highest power raised to the highest derivative. So that is why the degree of this equation is always 1. That is how the degree is explained. Next example we shall see dy by dx whole square. Dy by dx whole square we will see. Now in this equation, second equation, you can see dy by dx whole square plus dy by dx minus sin square y is equal to 0. Now the derivative is dy by dx. The power raised to the derivative is 2. Therefore, the lowest power is dy by dx whole square plus dy by dx minus sin square y is equal to 0. The power raised is how much here? It is 2. Therefore, the degree is 2. Very simple. The highest power raised to the derivative, highest derivative is the degree of the equation. Therefore, in this case, what we do, we will write here. In this case, the highest power or the power raised to the derivative dy by dx is 2. Therefore, degree is 2. Here. In the third example we will see now. We will have one problem here. You can see dy by dx plus 2x into dy by dx is equal to 0. See, this is a special case. This is not at all, though it is a derivative, it is not a differential equation. This is a special case. So bear it in mind, whenever equal power of derivative is there, there is no degree. You cannot write the degree. We cannot write the degree because suppose if I put dy by dx is equal to p, what happens here? P plus 2xp will be equal to 0. So it is not a differential equation at all. We cannot write the order, or either order or degree. That is, this is not a valid differential equation. This is not a valid differential equation. That is how we have seen 3 different types of degrees, how to find out the degree of a differential equation. Now we shall find out the degree and order of differential equation of different differential equations here. We have written serial number, type of differential equation, order and degree with this tabular column. Now we have written here the differential equation. Now the degree and order we have to write, or order and degree we have to write, anything. See, the order is 2. The highest power of the derivative is called the order. So here highest power of derivative is 2. Therefore we have written 2. The degree is the power raised to the highest power, highest derivative. So here it is power raised is always 1. Therefore degree is 1. Similarly, in second case also, the order is 2. The power raised to this highest order, highest derivative is 1. Therefore, it is degree. So, order is 2 and degree is 1 for the second problem. Third problem. Here, only one derivative. You can see dy by dx here. There is, order is 1, degree is also 1. In third case, order is 1, degree is 2. In fifth case, degree, the order is 2, the degree is 3. The order is 2, degree is 3. In sixth problem, we have highest degree, highest order is 2. But because this 2 and this 2 get cancelled, dy by dx whole cube. So here you cannot say the degree, the order is 3. Because the highest derivative is called the order. That is 2 is the highest order. And degree, to this the power is raised is 1. Therefore, degree is 1. So, we have seen for different differential equations, the order and degree of different varieties. So, that is the problem. We shall see the problems on formation of differential equations. Here, form the differential equation for the family of circles touching the y-axis at origin. Now, the center is A0 for such a circles. Center is A0 and radius is A. Now, the equation is given by x minus a whole square plus y minus 0 whole square is equal to a square. Here, x minus 0 means x minus h whole square plus y minus k whole square is equal to r square. That formula we are using here. That is very important. If you want, you can make a note of that. See, here we are using the equation of the circle as x minus h whole square plus y minus k whole square is equal to r square. This formula, we are making use of this formula here. So, x minus h is a, x minus y minus k is 0 here. That formula we have used here. You can make use of that formula and expand this. X square minus 2ax plus a square plus y square is equal to a square. This a square get cancelled. Therefore, x square plus y square is equal to 2ax. Therefore, 2a is equal to x square plus y square by x. Now, differentiating using u by v method. This we taking is u and this as v. Now we know the formula for u by v differentiation is v into differential coefficient of x square plus y square. That is, differential coefficient of x square is 2x plus 2y into dy by dx minus this u x square plus y square into differential coefficient of v is 1 always divided by v square, that is x square. V is x square. Now when you cross multiply, this becomes 0. Therefore, 2x square minus x square is how much? 1x square. Minus into plus minus y square. Plus if you multiply this with this 2xy into dy by dx, we have written y dash. It is always dy by dx is written represented by y dash. This is equal to 0. So this is the required equation of the differential equation. This is the required differential equation. Now second problem. Form the differential equation for the family of parabolas having vertex at the origin and axis as positive direction of x-axis. Positive direction of x-axis. Now the equation of such a parabola is y square is equal to 4ax. Y square is equal to 4ax. Now we will differentiate both sides with respect to x. This is 2y into dy by dx is equal to 4a into dx by dx. Dx by dx is 1. So therefore y into dy by dx is equal to 2a. Y into dy by dx is equal to 2a. Now substituting this value of 2a in 1, we get, see here, y square is equal to, I am splitting this 4a into two parts here, you can see, 2 into 2a into x, 2 into 2a into x. What is the value of 2a? Y into dx, that I have substituted here. So 2 into y into dy by dx into x. Now this y and this y get cancelled. Therefore 2x into dy by dx minus y is equal to 0. This is the required differential equation for this family of parabolas. Now after going through the order and degree of differential equations, now we are going to start this general and particular solution of differential equation. General and particular solution of differential equation. See, what is meant by general solution and what is particular solution? In case of general solution, the solution obtained in solving the differential equation contains arbitrary constants, which contains arbitrary constants. For example, A, in this case, A and B are called arbitrary constants. So the solution obtained with arbitrary constants is called general solution. But in case of particular solution, these arbitrary constants are eliminated. They are eliminated by substituting in the equation suitably. That is what we will see here. The solution obtained in case of differential equation which contain arbitrary constants is called general solution. The solution obtained by substituting the values of arbitrary constant in general solution is called particular solution. That means to say the particular solution will be free of these arbitrary constants. So that is the meaning. Now this can be proved by taking one example. For example, say here, he says one problem, let us see one problem. Verify the function y is equal to a cos x plus b sin x, where a and b belongs to R, is a solution of differential equation a square y by dx square, d square y by dx square plus y is equal to 0. This is the example we have taken. Now, what we are going to do, in the first step, what we are going to do, we take this y is equal to a cos x plus b sin x. Second step, we differentiate both sides 2 times. First time we are differentiating here, you can see here, dy by dx is equal to minus differentiation of cos x is sin x, differentiation of sin x is cos x. Therefore, minus a sin x plus b cos x. So this is dy by dx. But our solution is different. We have to differentiate 2 times. So d square y by dx square is equal to minus differentiation of sin x is cos x. Cos x is minus sin x. So minus b sin x. Now what is common in between? Minus is common. So I have taken a cos x plus b sin x. Now d square y by dx square is equal to minus, what is a cos x plus b sin x is equal to? Y. That y we have substituted here. Instead of a cos x plus b sin x, I have substituted d square y by dx square is minus y. Now d square y by dx square minus y I will transfer to this side. It becomes plus y. On right hand side it will be 0, which is the required solution of the differential equation. Is it not? So here you can see here, it is free from arbitrary constants. The solution is free from arbitrary constants a and b. There is no a and b at all here. So that is how, this is the particular solution for the given equation. Now we are going to see, form the differential equation by eliminating arbitrary constants in the given equation here. Y square is equal to a into b square minus x square. We have to form the differential equation. See this, we are writing it here. Y square is equal to a into b square, ab square, minus a into x square, ax square. Now y square, this minus ax square I am transferring to this side, plus ax square is equal to ab square. Now differentiate both sides. Now this is 2y into y dash. This is the differentiation of dy with respect to dx and dy with respect to, first we have to differentiate with respect to y, then with respect to x, second we have to do it. Plus this is 2ax is equal to 0, or 2ax we will keep it on left hand side and transfer this 2y dash to the right hand side. It becomes minus 2y dash. This 2 and this 2 get cancelled. A is equal to y dash ax. It should be ax is equal to y dash. So ax is equal to y dash. Therefore a is equal to minus y dash divided by x. Now differentiating again both sides, we are using the formula u by v method. Here we are using u by v method, that is v into du by dx minus u into dv by dx. Differentiation of x with respect to x is 1, and here you can see this y dash we are again using uv formula. See, minus y into y double dash minus y dash into y dash plus y dash into 1 divided by v square. V square is x, that is x square. It becomes. Therefore, now when we cross multiply this, this becomes 0. And here x, y double dash, this I am taking minus, everything minus outside. X, y double dash plus x, y dash whole square. See, y dash 2 is there. Y dash whole square minus, I have taken minus outside, therefore it becomes minus, plus becomes minus, y dash is equal to 0. So hence this is the solution for the above differential equation. Okay, now we will see the second problem. Here y is equal to a e to the power of 3x plus b e to the power of minus 3x. Now y dash is equal to, differentiating both sides, here we will write differentiate both sides. What we get? It is 3a e to the power of 3x because differentiation of e to the power of ax is a e to the power of ax. That is, differentiation of e to the power of 3x is 3a e to the power of 3x minus 3b e to the power of minus 3x, because e to the power of minus 3x is minus 3 e to the power of minus 3x. Now again, once again, y double dash, you will see. Now this is 9 a e to the power of 3x. Are you following here? 3 3s are 9 minus, if this is minus into minus, it becomes plus 9 b e to the power of minus 3x. B e to the power of minus 3x. Therefore, what we get here, y double dash is equal to 9, I will take common, a e to the power of 3x plus b e to the power of minus 3x. A e to the power of 3x plus b e to the power of minus 3x. Therefore, y double dash is equal to 9y, because a e to the power of 3x plus b e to the power of minus 3x is y. So we have substituted here. Therefore, y double dash minus 9y is equal to 0 is the differential equation. Is the differential equation for this. So that means to say, here we have transferred this 9y to this side. So y double dash minus 9y is equal to 0 is the differential equation. See, you can see here y we have replaced because it is equal to y. A to the power of 3x plus b to the power of minus 3x is equal to y. That is why we have replaced it by y. That is how it becomes y double dash is equal to 9y, y double dash minus 9y is equal to 0. This is the differential equation. Now we shall see this problem. See, it is the equation for the hyperbolas, rectangular hyperbola. X square minus y square is equal to c square is the equation for the rectangular hyperbola. Now for this we have to find out the differential equation. Now what we do, we will write first this equation, x square minus y square is equal to c square. This is the given equation. Now we will differentiate both sides. Differentiate both sides. What do we get here? If we differentiate both sides, we get 2x minus 2y y dash is equal to 0. Differentiation of constant is always 0. Now these 2 and these 2 get cancelled. Now y dash is equal to x. Y dash is equal to x. Now we will differentiate once again. What do we get? We will see. Differentiate. Now differentiating both sides again. Now y double dash plus y dash into y dash is equal to 1. See here, UV I have applied this method. U into differentiation of y dash is y double dash plus V into differentiation of y with respect to x is y dash. So therefore what happens here? It becomes y double dash plus y dash whole square is equal to 1 is the required differential equation for this. Is the required differential equation for the, here we will write, is the required differential equation. Here, what is that we have observed here? It is a very simple problem. You can see. See, differentiation of x square is 2x. Differentiation of y square is 2y, y dash is equal to 0. You can leave at this stage itself because there is no arbitrary constants. You can leave the problem at this stage itself. But still we can go and do the problem in further steps also. So that we get y double dash plus y dash whole square is equal to 1, which is the required differential equation. Now we will take this problem. Cy square is equal to x square plus y. We will write that problem here. Cy square is equal to x square plus y. Now y square, c is equal to what? We will see now. C is equal to x square plus y divided by y square. C is equal to x square plus y divided by y square. Now this becomes u by v. When we differentiate this, differentiate both sides, d of u by v divided by dx, d of u by v divided by dx is equal to v into du by dx minus u into dv by dx divided by v square. This formula we are going to use it now. Now when we differentiate this left hand side, it is a constant, it becomes 0. Now u by v, v is what here? Y square. y square into, I am differentiating u. What is differentiation of x square? It is 2x. Plus what is differentiation of y? It is y dash. Understood? Y becomes y dash. Minus u is what? X square plus y. I have written like this. Now dv by dx is dy square by dx. That is, it becomes 2y y dash. 2y y dash divided by y to the power of 4. This becomes v square, This becomes y to the power of 4. Therefore, we will multiply now. This becomes 0. Now, it is 2x y square plus y square y dash. 2x y square plus y square y dash. Here, minus 2x square y dash minus 2y square y dash. This is equal to 0. Can you see here? That is, here you can use this formula here. You can take out y square common, y square into 2x plus y square, 2x plus y dash. In this, what we get here? Minus 2y, we will take out common, 2y y dash. If you take out common, 2y y dash we have taken common, x square plus here, how much it is? Y. This is equal to 0. So this is how the required D. Now this is the implicit function equation. X square plus y square minus 2ax plus 1 is equal to 0. This is the implicit function. Now what we are going to do, now I will take it like this. Differentiate throughout. Differentiating. Now we will first write the problem like this. X square plus y square minus 2ax plus 1 equal to 0. Now differentiating throughout. Differentiate throughout. What do you get here? Differentiation of x square is 2x. Differentiation of x square is 2x. Plus differentiation of y square is 2y y dash. 2y y dash. Minus 2a. Because differentiation of x is 1. 2a into 1 is 2a. This is equal to 0. Therefore, 2a is equal to 2x plus 2y y dash. Now in all this we have a 2 common. Therefore what we do? A is equal to x plus y dash. X plus y dash. Again differentiate. Differentiating both sides. Now this becomes 0 because differentiation of a constant is 0. Differentiation of x is 1 plus here it is ub y double dash plus y dash into y dash. Y dash into y dash. Therefore, your differential equation becomes y double dash plus y dash whole square plus 1 is equal to 0 is the required DE. Is the required differential equation. See here, it is very simple problem here. See, you can see This is implicit function. You have to differentiate throughout first. Afterwards, find out the value of 2a, because it is an arbitrary constant which has to be eliminated. So 2a, we have written 2a is equal to 2x plus 2y dash, because this minus a, 2a, we have sent it to that side. So it becomes all 2 get cancelled. A is equal to x plus y dash. Now differentiating this a, it becomes 0. Differentiation of x is 1. Now this is uv. U into dv by dx, that is y double dash. Y dash becomes y double dash, plus v into du by dx, that is y dash into dy by dx is nothing but y dash. Therefore y double dash plus this becomes y dash whole square plus 1 is equal to 0. So this is the required differential. Now we see the formula, problem here. Sixth problem. Form the differential equation of the family of circles touching the y-axis at origin. Touching the y-axis at origin. Now solution for this. For such a family of circles, the center coordinates are a comma 0 and radius is a units. Radius is a units. Now the equation of the circle becomes x minus a whole square plus y minus 0 whole square is equal to a square. That is x square plus y square is equal to a square, Same formula we have applied here. Since the center is transferred to a0, we have x minus a whole square plus y minus 0 whole square is equal to a square. Now this we are applying a minus b whole square. X square minus 2ax plus a square plus y square is equal to a square. This a square and a square get cancelled. Therefore x square plus y square is equal to 2ax. Now therefore x square plus y square by x is equal to 2a. This x I have brought it down. Now differentiating both sides, we are applying u by v method. So v into, that is x into, what is differentiation of x square? It is 2x plus, what is differentiation of y square? It is 2y dash minus, now this u into dv by dx, that is x square plus y square into differentiation of x is 1 divided by x square is equal to 0. Now when you cross multiply this, this becomes 0. Now here 2x square plus 2xy dash minus x square minus y square is equal to 0, or 2x squared minus x square is x square minus y square plus 2xy dash is equal to 0, or y dash is equal to, I will transfer minus y square to that side, it becomes plus y square, plus x square to that side, it becomes minus x square, divided by 2xy. So y dash is equal to y square minus x square by 2xy is the required differential equation for the family of such circles. Now see this problem, seventh problem. Form differential equation of the family of circles having center on y-axis and radius is 3 units. Radius is 3 units. See solution. For such a family of circles, the coordinates of center is 0, 3. The coordinate of center is 0, 3 and radius is 3 units. Therefore, the equation of the circle is x minus 0 whole square plus y minus 3 whole square is equal to 3 square. So that is x square plus y square minus 6y plus 9 is equal to 9. This 9 and this 9 get cancelled. Now minus 6y I am transferring to this side. So x square plus y square is equal to 6y, or x square plus y square divided by y is equal to 6. Now differentiating both sides, we are applying u by v method here also. So v into 2x plus 2y into y dash minus u into x square plus y square into differentiation of y is y dash is equal to 0. Now when cross multiply this becomes 0. Therefore multiply 2xy plus 2y square y dash minus x square y dash minus y square y dash is equal to 0. Now 2y square y dash minus y square y dash becomes 1y square y dash. 1y square y dash minus x square y dash. This we have taken y dash common. Here it is 2xy plus y square minus x square y dash is equal to 0, or y dash is equal to, this I am transferring to that side, it becomes minus 2xy divided by y square minus x square. So this is the required differential equation. Eighth problem, form the differential equation for the parabolas having vertex at the origin and axis in the positive direction of x-axis. See here, the coordinates of focus is A0. The coordinate of focus is A0. And the equation of such parabola is y square is equal to 4ax with focus A0 as the coordinates of the focus. Now y square is equal to 4ax, we are differentiating both sides. It becomes 2y dash is equal to 4a because x is one differentiation. Now substituting this value of 4a in the original equation, y square is equal to 4ax. I am substituting the value of 4a. Now y square is equal to 4a, instead of 4a I am substituting 2y dash into x, or y square minus 2xy into y dash is dy by dx is equal to 0. So this becomes the required differential equation. Here, what we are observing here, somehow we have to eliminate this arbitrary constant 4a. We have to eliminate somehow arbitrary constant. Whether you differentiate this and eliminate this 4a, or substitute this value of 4a in the original equation, both are same. Even if you differentiate this, it becomes 2y double dash plus, like that it comes. So you need not worry, only our main objective is to eliminate this 4a. Somehow we have to eliminate this 4a. Therefore what we are going to do, very simple. We substitute the value of 4a in the original equation here. That is what I have written. Substituting the value of 4a in y square is equal to 4ax. So thereby we get y square is equal to 2y dash, because 4a is 2y dash into x. Hence y square minus 2xy dy by dx. In dy by dx we have to write here dy by dx is equal to 0 is the required differential.